So arc length is a distance measurement. It's similar to finding the actual length of a line segment. And it's important for you to note that arc length is not the same as arc measure. We've formerly been just looking at the measure of an arc. And so let me remind you that arc measure, that's when we measure it in degrees. It is a fractional part of the fact that an entire circle is 360 degrees. So when we're finding one little measure of an arc, we're finding a fractional part of that. And to find arc measure, you need those angle relationships that we learned about for central angles and inscribed angles, interiors and exteriors. Okay, but arc length is going to be different. It's actually going to be measured in units like centimeters or inches or feet or yards. Anything that you could measure length in, you can measure arc length in. It's actually a fractional part of the total circumference. And remember, we talked about the fact that circumference is the distance all the way around the edge of a circle. And so arc length is going to be just a portion of that. And to find arc length, you need two things. You need a central angle and you need the radius of the circle. And the reason you need those two things is because there is actually a formula for arc length. And it's a formula that's on the formula sheet that you would use when you take the milestones. And this is what it says. It says 2 times pi times the radius times this right here. We've talked about it before, but it's been a while. That is the Greek letter theta, but it represents the fact that we need a central angle. So you will actually plug a number in the place of this theta, and then you'll plug in a number for the radius, but then the rest of it stays the same. It's a fraction. It has 2, it has pi, it has 360 in the denominator. And so if you can plug in numbers for radius and for angle, then you type this into your calculator and you find the arc length. So an example would be like this one right here. It says find the arc measure and the arc length of the arc intercepted by a 40-degree central angle and a circle that has a radius of 18 centimeters. Well, remember, arc measure, that's just where we'd say, oh, we have the central angle. Well, the central angle is equal to the arc that it measures. So we would just say, oh, arc measure would just be 40 degrees. Now, if we're going to find the length, that's this new thing that we've talked about. That's where we need the formula. And instead of 2 pi r theta, I'm going to plug numbers into those places all over 360. Again, this is supposed to be the radius, which they said was 18. This is supposed to be the central angle, which they said was 40. And so I plug in those numbers just like that. And then I can type this into a calculator. I make a fraction. I say 2, and then I say pi, and then parentheses 18, new parentheses 40. I arrow down, hit 360, hit enter, and I get an answer that looks like this. So I could say my answer is that arc length is 4 pi centimeters. This is what we would call the exact way to write that answer. It's exact because it still has the pi symbol in it. If I did want a decimal, I could turn it into a decimal in my calculator and say the length is approximately 12.57 centimeters. Notice I didn't even need a picture in order to solve this problem because they gave me the information I needed in words. Here's one more example. It says find the length of the arc AB, and it says leave your answer in terms of pi. Remember, arc length, that's this formula, and I need numbers that I can plug in for radius, and I need number that I can plug in for the central angle. Notice they gave me the central angle that goes with arc AB. So I know that the theta that I need is 25. And then also notice they didn't give me the radius. This is actually the diameter. But if the diameter is 20, remember I can divide the diameter by 2 to get that my radius is 10. So then I plug this number in here. I put it all over 360. I can put this into my calculator and I get an answer of 25 over 18 pi.